Hi there. This is a spreadsheet I've created for building a septic system off a set of plans. So I created this spreadsheet a couple of years ago, and it's kind of been in evolution. But I've designed this to try and simplify the work we do in the field and to eliminate the mistakes made by calculating things in field, hand calculations. It was always something I made mistakes on, and I created this spreadsheet to eliminate that. So I'll just kind of go over it, and anybody who's reasonably savvy with Excel could create a spreadsheet similar to this. It doesn't have to be super fancy. But it does the job. So in this case, everything revolves around the engineer's plans. So the first thing we do is use the benchmark elevation to set the height of our rotary laser. So we take the benchmark elevation, we'll set up our laser, and we'll measure it. So in this case, we'll just call it 2 feet. So it sets up the height of instrument for 52.42 feet. What I do is I take all of the inputs from the engineered plans and I input them into the spreadsheet, and I use it to calculate my receiver settings on a grade rod. So in this case, the building invert is 40.5 feet, and my rod setting for that to achieve that elevation would be 11.92 feet. So if I was going to move my tripod on the job that day or the next day, all I need to do is come back and measure my benchmark elevation at a different height of instrument. Say it's 2.5 feet. All of the rod settings will readjust. So you can make this calculator for anything you want, really. But in this case, the more important thing is we have a rod setting for the invert height, which is the flow line. And then we have a top of pipe measurement, which that's when we actually use to verify that the top of the pipe is correct. So what I'll do, that top of pipe is dictated by the invert height, which is the distance from the top of the pipe to the flow line of the pipe. That's what the definition of the invert is. So over here, that invert height's in inches. And in this case, I made a pull down, which references another sheet. So I have all these different pipes that I've used. So 4-inch Sked 40, 4-inch Sked 80, 6-inch SDR 35, 6-inch Sked 80, 4-inch cast iron, 4-inch clay. And you can populate those dimensions here in this table, and they show up over here. You don't need to do that. You can just put it in inches, convert inches to feet, and you're good. So in this case, if I want to use Schedule 80, it changes the input. So some jobs, you might have different invert heights all over the place, so you can input them in here. So again, that's all depends on how fancy you want to get. But the bottom of the tank elevation, I have this one in red because it's important to me in the field, because this is how deep a hole we need to dig. So what we do in this case, we take the invert height of the tank, inlet or outlet. So we take the septic tank inlet elevation, subtract 54 inches, and that works out to 41.25 feet. I have a conversion from inches to feet in the calculation that spits it out, but more importantly, it spits out the grade rod setting. So if you can set the receiver on the grade rod and dig a hole to that elevation, you put the tank in, I guarantee you'll have that invert height. I do this on every job, and we're within hundredths every time, because we're within the error of which we can dig the hole and set the component. So so in this case, I've got one for the septic tank, I've got one for the pump chamber, I've got one for the D-box height, and then I have some field information. So I have an invert into the field. There's the rod setting. Invert end of field. If it was pipe and stone, it's pitched. Might be the same, might be different. That all depends on what you're building. Bottom of soil absorption system, chamber of stone. That's an input from the drawing. Bottom of field excavation. Again, that's an input for the drawing. It spits out a grade rod setting. A couple other things here. I made a trig calculator. We're always trying to set the excavation, which is a rectangle or a square, but you know, we need a corner dimension. So, you know, a 32 by 20 field has a corner to corner distance of 37.74 feet. So we have that. I've got another calculator over here. 4.25 inches equals 0.35 feet. You know, 4.6 feet is 55.2 inches. So again, just to help me out, I create this sheet and keep duplicating it over and over again from job to job. We can always go back and look. I have a section in here I've added for as-built. So if the engineer's not going to come out and measure your components, you can create your own as-built. You have to be careful with this one. This uses the height of instrument that you manually input. That way, if you've measured the job, and the next day you might set the tripod up or the laser up again. So you have to be careful with this one. I have a spot here where I can enter the measured height of whatever you enter in the grade rod. Say you set the receiver up on a component and it measures 5 feet, it spits out the elevation. You can manually drive the elevation in there. You just got to remember what you're doing. Again, it's however what works for you. You can set this up, but this is basically free to do on Google Drive. So you can click over on my spreadsheet, and I've got dozens of these set up, and I've got a couple different formats I use. I use one for doing sewer connections, just so we can make sure we get slope and things like that. But it's kind of a nerd way to do it, but it certainly helps make a mistake-proof system and saves a lot of time in the field. So thanks for watching. Have a good one.